Hi there, welcome back to the channel and welcome to the build video and testing of the final version of the capacitance leakage tester, the one that goes under the rack over there. It's already there. You can't see it from here. You'll have to watch the video to figure out what it looks like. But this video is showing you how it got from that prototype version with a mistake on the board, as I mentioned, to this final version, which I've got to tell you, see for yourself. It works very, very well. I love it. I really love it. It's actually my favorite under rack project so far. But I got the boards from PCBWay and I want to thank them for their sponsorship. It's great. They came out fantastically as usual and I made no mistakes this time. So I'll be sharing that in their share section of their website so you can order your own and build your own if you like. I hope that the information that I've provided, both in the first video and in this final one, and in the schematic, which I'll also be sharing with you, I hope that serves to help if you want to build it. I know a lot of people built the first version. And something I want to say about that, you don't have to build this with that DC to DC converter module. You can use the original transformer. The transformers are a lot more expensive. That's why I decided to try this one out, and it actually works very well. The other one, the boards allow for a transformer as well. So it's your choice, okay? This video is to show you how I got it from that first version with mistakes to the final version on there and tested and working like a charm. Hope you stick around. Enjoy the video. Well, folks, I've been waiting for this day. The boards arrived from PCBWay, and this is the result. They are slightly smaller than the previous ones. I've also made a few little changes about how I've organized everything on the board. This is the part that's going to be facing the back, the one that you'll be able to see. This side is the one that's going to be facing the front, so the switch is going to come out here. The rotary switch, the toggle switch out here, and the pot over here. Now you'll notice that some of these solder connections are behind the pot, which means I have to solder them all very carefully, leave as little wire as possible protruding so it doesn't touch the pot. And I will use a rubber pad isolator to place on there, one of those self-stick ones, and make sure that when the pot rests on there, it doesn't actually short any of that out. So what I'm going to do, well, actually, there's something else I want to show you first. This box. Look what I received. These are 0 to 500 volt little voltmeter, LED voltmeter modules. They are 3-wire, which means that you power them with up to 12 volts, or actually it's more than that, up to 30 volts. And then you use this reference to the same ground as your measure sensor. So what I want to do is see if I can use this to measure the B+ or the supply voltage that's going to the device under test. 500 volts, I'm not sure how accurate this is going to be. I don't need it to be accurate. Remember, you're not doing, scientific measurements here. You're measuring for approximate values to supply across your capacitor. I'm interested to see whether that'll work because that was going to be over there. Now, obviously not over there because now that I've got everything, and I want to thank PCBWay before I carry on for supplying the boards and sponsoring the video. As usual, the boards came out fantastically. Here they are, and they always send a few little gifts, which are always welcome. And I'm almost ready to start cutting this up, drilling this up in order to do the final one. So what I'll be doing is taking some of the stuff from that prototype and putting it on here. I'll be making sure that I don't mess this up. Things like the holes that I have to drill over here. I'll make sure that I've got everything in the right place. I don't want to have to waste one of these. I don't have that many left. And getting it from my aluminum supplier is not as simple as you guys might think. This is Madeira after all. Okay, one other thing that I need to mention is that this guy over here, as some of you have mentioned, this thing's got some pretty cheap capacitors over here, and they're high voltage. I think they're 400 volts. Anyway, I'm going to replace these with better capacitors. I don't trust them. These capacitors are probably what makes me most nervous about these little cheap modules. I just don't want to take a chance. And I'll be ready to scavenge as many of these components from here as I can to fit on the new board. And we'll be ready to get cracking. So one step at a time. Let me first tackle this, see what we can do about that. So that's one step done. These capacitors have been changed. I've got the old ones here. I really don't trust these guys. These are not exactly Nishikons because the Nishikons didn't fit on here, but I bought this from a reputable supplier, so I know that at least they should be rated for what they say they are. Okay, onwards. And here we are. Everything soldered, everything in place. This is the result of my removal of the old components. Nothing left there except those tag things there, which I don't really mind. I was able to use everything again, which is great. I'm a bit of a miser in that regard. I hate wasting components. And everything is set. Now, what is the difference? This is going to fit like this, forwards. So switch on top, then the pot, then that switch there as well. And this time I got the switch pins correct, so no hacks necessary. Everything fits nicely. The components underneath that, or rather underneath that, so these components over here, I cut the leads very, very short, so they just protruded through the board, soldered it. Remember, this board, or these pins, or these solder tags go right through. So when I solder on this side, the solder runs to the top, make sure that the contact is good. And that means that I don't have any long leads sticking out here because I didn't want them to short to the pot. The pot has got a separation here, one of those feet, just to make sure that it doesn't touch. And it also needs to come up a little bit to get it to the same level as the switch, which is a bit higher. Obviously, I'll need to use some washers to make sure the separation is exact. This one is easy. There's a dual nut on here. And it's looking good. Now, this part was actually very, very easy. The boards came out fantastically. No problems at all. Let me show you the challenge. This was a challenge. This was a challenge because aluminium is soft. Yes, it is. But when you need to drill them, or drill all this in, well, at home. I don't do this in a shed or in a garage or in a workshop itself. It's my workshop at home, which is part of an apartment. So, yeah, it gets a little bit tricky. Anyway, I drew the board up, or the faceplate up on a graphic program so that I can get everything nicely aligned. Obviously, I took the spacings here from the actual PC board that I had, made sure everything was correct, and then started drilling. The drilling is not a problem. The problem comes in when you get to these squares and this cutout for the meter. Yeah, a lot of filing, a lot of frustration, but it seems to have come out extremely well. Let me show you. When I take the board and fit it through the back, it's coming through perfectly. I need to move that little washer or that nut a bit further back, but it comes through perfectly. And this, what I did here is I had these two soldered in. The switch itself, which requires a smaller hole, I didn't solder it in. I put it into the hole and then fitted the board from the back and then soldered the pins. It's a little bit trickier, but at least you know that it's going to fit well. And that is now done. So this is ready to fit in here and get cracking. But there's one more step you need to do before going crazy. First of all, the back. I need to fit this inside there. And I've checked spacings. I've fitted everything else in here and the meter as well. Made sure that this thing can fit in here. I was going to put it like that and decided to do it in reverse. The spaces are just enough to clear the back. And the reason is I wanted a little bit of insulation between the transformer, which is probably the noisiest, well, not so much, probably the MOSFET and the transformer that are fairly noisy. And I wanted to put them a little bit shielded, as it were, to the back of the casing. This thing goes on here, actually the other way around, but it goes on here. And then we've got the DC jack that goes on there. switch and a LED that goes on there, but everything else fits well. And then I had to do the faceplate. Now, how do I do that? What I did is on one of the graphics programs, I do the layout that's 200 millimeters by 65. I've got the holes on there, which I then hide when I print them, and I put all the labeling that I want. And I then export this as a PDF. You'll notice I've got two. Sometimes I mess one up. This is printed on one sheet of paper that has a sticky side. So I went to a print shop just near the house here and asked them to print it on this. The outline on this one is darker than that one. I'll probably use this one because I cut it on the actual outline. I don't need that. This gets stuck on the front of this guy. And then I stick a layer of self-stick transparency over the top before I then start cutting out the holes. And that has worked for me. It's worked pretty well. I could just use that paper and spray it with lacquer, but I found that the actual layer of transparency protects it a lot better. Time to get cracking. Well, folks, it looks like we've got progress. Look at that. Don't worry, I'm going to show you the insides and tell you what I did, but I just wanted to show you the result. It came out fantastically. I'm so chuffed. I am so chuffed. And it's literally ready to go onto the bracket under the shelf. It's just doing a bit of a twirl. And then I'll show you what I've done inside and explain some of the challenges that I may have faced. Quite honestly, there weren't that many. You just have to be careful when you wire this up. Test every stage as we go along, but let me give you a closer look. Now, the front is obviously self-explanatory. I put the switch in there, the LED I'll show you how I wired it up inside. I've got the output to the device under test, the positive and the negative. That is polarized, obviously. The little LED voltmeter fit in there beautifully. What I've done is I've used a bit of hot glue at the back It sort of fits in quite tight, but I wanted it to stay flush. As you can see, it is flush. And the reason I wanted to stay flush is I'm thinking of perhaps getting a bit of a, a polarized or a colored piece of Perspex, a red one, so that I don't see anything except when it's lit up. And then I'll just fit it over the top, maybe glue it over the top, make it a slightly bit bigger than the actual module, and then fit it over the top so it'll look more professional. The switch, I just put a high on there, and I've made a change here, and I'll tell you what it is. That's the normal, that's high. Okay? Now, what is the change? Well, here we've got the volts, minimum and max. All right. And the change that I've made is I've used the original 1 mega ohm pot, which I had on the old one, and I've still got the two 220k resistors on top and bottom. I'll make that change on the schematic, which I'll link to below. But the reason I left it as put the 1 meg in is for two reasons. One is it's the pot that I've got there was a slightly higher powered pot. The one that I've got here, the one that I was using to test with it, this one, is also fairly high power compared to some of those small ones, but this shaft was too long, so I couldn't get the knob on properly, and I just didn't like it, and I couldn't do anything about that. I couldn't shift it back because it's obviously spaced with the PCB at the back. So I decided to use the original one, and then the idea was I'd order another one, but then I started liking it, and the reason is I can now leave it on low, or rather I can leave it on high, and I can go from about let's see, it's 10/12, right? 10/12, 80 something percent. So probably about 20 volts, like it used to do. When it's on minimum, it'll be about 20 volts to the total max of about 330, which is what I'm going to set it for. And if I want to test low value, then I just do that, and it goes from 0 to about 310 volts. So I think in most cases, I'll just leave it on there. I just know that it won't start at 0, which the other one didn't do either. The other one started at about 30 volts anyway. Then I've got the various ranges, and I had to put it on this side. It doesn't matter, it just depends on how you fit the knob. You can put the markings anywhere. This is a question of space. I'll put it on this side. So the idea is still the same. It's clockwise. So you start at off, you click into 100 milliamps. If it's not jumping like crazy over there, you put it to 10 milliamp range. If it's still under, you put it to 1 milliamp range, and if it's still under 1 milliamp on that range, you can then put it to the 100 microamps. So, and then when you do the reverse, you switch it off, you do that, switch it off, and the device under test is then shorted to ground via a 47k resistor to discharge it. Okay, that is the front. And as you saw before, all the covering here is nicely protected with the printed version plus a transparent layer at the top. Now let's look at the back. At the back, I've got 3 holes which hold the PCB of the voltage module, the high voltage module. Those fit exactly. I'll show you through the top. And I've also got a hole in here, and that hole leads me or gives me access to the trim pot at the back of that PCB, which allows me to adjust the range. At the moment, I've got 100 volts. I haven't changed it, but I can change it without having to remove that PCB from the enclosure and just go through the back. I use a ceramic or plastic screwdriver, and I can adjust that to the maximum voltage that I want. As I said, I'm going to leave it at 330 volts. Here's my DC input, 12 volts DC or so, and I made a note here that the center is positive. This is always important. If you don't do that, because mine is switchable, I've got the plug that I use at the end of my leads, I can flip it around. I always test it because you don't want to reverse polarize this thing and blow it up. It could have been as simple as saying, as putting a diode in there to protect against reverse voltage, but I'd lose 0.7 volts. Wouldn't make much difference. But anyway, this thing's at the back, and I'm not sure exactly how I'm going to power it at the moment. In the meantime, I'm going to be powering it. When I need it, I'll just connect this to the power supply, 12 volts, fit it in the back. It'll go easily on the back. I can see where it is. I can feel where it is, plug it in, and I'm ready to go. So I'm not sure whether I'm going to buy a dedicated wall wart to put it at the back, which I could do. In fact, I think I've got 12 volts on one of those other devices. I think I've got a 12 volt supply on the workshop amp. I might be able to piggyback on that as well. I'll think about it. Anyway, that is there. Now, let's look at the inside. Okay, one step at a time. The switch. Power comes in here. Be careful, these switches have got 3 tags. One of them is to cut off the earth, the ground, so that you can use it in a battery system. In that case, they usually use reverse polarity on here, so be careful. The positive comes to the top of the switch. Switch is switched on when you put it down, so it's the top 2 leads over here that work. This is a single pole double throw, so it can switch on either way. Use the top 2. And then the supply goes to 2 places. One, it goes to the board over there, which is wired underneath. That's the little high voltage module. And the ground of that comes to the ground of the input here. Okay, so that's supplying our little module, our high voltage module. And then the output of the module comes to there. Now, I removed that screw connector, and the reason is I was having a few problems with actually fitting it in there. Once I put everything in, actually going in there and screwing it in, because of course I had to get the screwdriver over there. And then I thought, well, I don't want it to slip. I mean, I could have very high voltage coming out of this thing, going to the board. If that thing for some reason came out of that, no, not there. If that came out of the screw connector, I would have up to 300 and something volts floating around. So I decided to solder it in, and it's very easy to access it from the top. So that's soldered in. And of course, what is next? Okay, then I've got the board itself, the actual PCB that I designed. It's got 3 of these connectors. One is for the voltmeter, one is for the device under test, and one is for the ammeter. They all fit nicely there, nicely tied up. The voltmeter one comes to here. This is the voltmeter module. Now those 2 wires are ground and sense. So it's the ground pin and the test pin, the voltage test pin. And the reason is I've put the positive to that switched supply over there as well. So the positive goes to the second solder tag over there. So I'm supplying positive from here, and I'm supplying negative from the connector point for the voltmeter. I wasn't sure how this thing was going to behave. I thought it might oscillate or it might go crazy like some of the others did, but this seems to be fine. So I'm effectively supplying this thing with 12 volts from my supply, because of course the ground is common. Okay, the ammeter, same story, goes to there. Now everything is nicely tied up in here. The actual voltmeter module, once I got it flush, I put quite an abundant amount of hot glue just to make sure it stays in place. Remember, this thing's going to be on the shelf, so it shouldn't be a problem. And I think that's about it. I found absolutely no errors on the PCB, so I'm going to be sharing this on the share section of PCBWay. You'll be able to either order direct or download the Gerbers. I'll also be posting on my Google Drive with a link in the description below the final schematic for this, where I'm going to mention that I changed this to a 1 meg pot. Okay, what else is there to say? Nothing much. Let me show you this thing in operation. I'm going to put it on the shelf already, and I can show you exactly how this is going to work. Oh, by the way, what I've got is that thing's got a bracket over there, like an aluminium strip, and this fits into that, so it holds in the front. And then at the back, I've got one of these L brackets. It's riveted to there, and over here I drill a hole on the underside of the shelf and I screw it tight, so it neither falls down nor does it go back. That's how I've got all those modules fitted on that under that shelf. I'll show you. Let me put it up and show you, and we can test a couple of capacitors. All right, this is it. It's on minimum. It is off. Switch on. Now look. That's minimum. On the lower level, you get 0 volts. If I up that, it starts at 59. Okay, so it's a little bit more than the 30 or whatever it was that I mentioned, but that's fine. I'm starting on minimum. I've actually increased that to 330 volts or so. Now, thing to do here is this. You've got to be careful, because whatever voltage you read on there, it'll be on here, unless this thing's off. So you've got to be very, very careful. This is high voltage. You can get zapped. So I use these leads with this type of clip, And the reason I use this clip is because there's little or less space for it to go wrong, less surface. Now let's test this capacitor. This is a, what is this guy? 100 volt, 250 volt DC. Let's see what happens here. There's no polarity because it's a, there we go, paper cap. Put that down. You don't want to touch it because there is voltage there. Now, I can leave it off and I can just give it a bit of voltage, 26 volts. Let me go to 100 milliamps. I've got nothing flicking on there. So I can go up. I can just see a little bit of movement on the meter there, on the needle. Let's leave it at 200 for now. There is some, it's about 2 milliamps. So I'm going to put this on the 10 milliamp range. Actually, there's more than 2 milliamps, there's 5 milliamps. That's 5 milliamps. Okay. As you can see, this thing's leaking like crazy. I'm not even going to the 250 because if I went to 250, it's just it's gonna be a sieve. Watch this. Well, there we go. 250 volts. It's leaking, what is it? On the 10 milliamp range, it's leaking 6.5 milliamps. This capacitor is so dead, it's not a joke. Now, if I click left and off, that voltage stays there, but the capacitor is now shorted to ground via a 47K resistor, which means that there should be no voltage on here. I'm still a little bit careful about how I touch it. Here's another one. Let's see, what is this? This is 500 volts, so we can go all the way up, but I don't start all the way up. That's on here, put it aside. I'm going to bring the voltage down, put it on, and then start upping the voltage. It's now on the 100 milliamp range, so I keep a lookout on keep my eye on the meter. I don't get much. Let me try a 10 milliamp range. There's some movement. It's obviously not at the full voltage yet, but I can see that's at 270. Now I want to up it. This is going to go all the way to 330 or so now. And I can do that because that's a 500 volt capacitor. Take it to the 1 milliamp range and it's measuring 0.2 milliamps. Again, totally dead. This thing is not supposed to be leaking at all, and it's leaking 1/5 of a milliamp. That is crazy, crazy, crazy. That capacitor is so dead, it's no joke. Okay, we shorted the ground again by putting it off. Let me put that on low just to be safe. This capacitor is a goner. Now I'm going to try this electrolytic. Now this one is, let me read it, 25 volts. This is a 25 volt cap and it is polarized. So you've got to be careful how you connect it. That's the positive. This is the negative, and this is where it gets tricky. If you had this on the upper range and you put this on 0, it would immediately zap it with 50 something volts, which is above that range. So you've got to be careful. It's down there, that's off, put it on. Now I'm going to give it some volts. Now, what happens here? 24, 25. That's as much as it's going to go. And it's leaking. Oh, it's about 18 milliamps. This thing is practically a short. That's dead. Okay. You see, it was leaking so much that it was actually bringing down the voltage because that capacitor, that transistor in the regulator circuit was starting to cut off. So it's doing its job. It's doing its job, which is great news. Anyway, there we go. That's been tested. That's off. So I can take this guy off. It's actually warm. Let's try this cap that came on a little module. I don't know how good they are, how bad they are, but we'll test it anyway. 35 volts. This is the 470 microfarad. 35 volts. Put it on there. Don't go up too high. Ooh, okay, you see that? It goes up and then it comes down. That's normal. That's whoa, careful. That's normal. That's what happens when you first put voltage on a electrolytic. It charges up. So I'm going to take it down. I'm down to the 1 milliamp range, and it's actually leaking almost 200 microamps. Now, over time, if I leave this for some time, I can actually see it coming down, coming down, coming down. That still seems to be quite a bit of leakage it still seems to be quite a bit. It's coming down to close to 100 microamps. It'll probably come below 100 microamps if I leave it long enough, but it's not a very good cap, is it? Take that off. Now let's get really adventurous. This is one of the 400 volt caps that came on that little module. Make sure you don't get the polarity wrong, so be careful. Don't touch it, we're going to go high. So let's give it some voltage. I've got it on 100 milliamps, which is fine. It's holding out okay. It's not bad actually. Let me give it, go all the way. See, there is a little bit of a deflection there, but if I 10 milliamps, it's less than 1 milliamp, so I can go up one range further. So it's at, what is it? Coming down to 300 microamps, 0.3 milliamps, and dropping. So it could drop down. I can't remember the formula for how much leakage is permissible in an electrolytic. It depends on the voltage rating of the capacitor. It also depends on the value of the capacitor, but it's certainly not 200 microamps. It's a lot less than that. So a case like this, I wouldn't even go any further. This is dead. For me, this one is dead. It's going to work. It's going to work, but it could actually heat up quite a bit. It's coming down. As the capacitor starts charging, carries on charging, the leakage current, the charge current drops, so that appears as a drop in the current over there. But this one's held up quite well. Okay, not bad. Off. Now remember, here's where it's important to get this to the off position so that your capacitor is discharged, and it takes a few seconds. The bigger the capacitor, the longer it takes. Now I want to try what is supposed to be a very good capacitor. This is a Nichicon KXL series. It is 450 volts, 47 microfarads. Again, be careful with polarity. Let's see what happens. Let's take it down. See the charge current as it goes up? Let's put it on high. 450 volt cap, no problem taking it to 330. Put it on 10 milliamp range, nothing. 1 milliamp range, it is at, well, I can see that less than 0.1 milliamp, so I can put it on the final range. That is a very good capacitor. And it's going to keep going down. It's at less than 20 microamps. And it seems to be going down. So you see the difference between a good capacitor, good quality capacitor, and a crappy one. Yeah, it's pretty obvious. Okay. Now remember, if I touch that cap now, I would get zapped. Not anymore because it's starting to discharge. Put that down, and off we go. So here's my bench at the moment. I've got 1, 2, 3, 4, 5, 6 modules. We've got the antenna selector, selecting between mini whip and the FM antenna, which is one of those internal ones that I've got on top, almost on the ceiling there. I've got an on-off switch because the mini whip is powered. I've got my capacitor leakage tester. This I'm so chuffed with. I can't tell you. This I'm so happy with, because for ages and ages, I've wanted to get this on this rack. Then we go a bit to the right. We've got a pi attenuator. This is the one, attenuates the signal from a signal generator. It's a switched attenuator. The moment they're all off, it can attenuate 3 dB, 6 dB, 12 dB, 24 dB, or any combination summed of those. It's got a dummy antenna, which I can activate or bypass over here. So this is very, very useful for the alignments. Then I go to the audio section, which are the last 3 over here. And first of all, I've got a receiver. It's an Aralic module, which receives both Wi-Fi and Bluetooth. And I can then stream any music or signal from my phone or any Wi-Fi or Bluetooth enabled device to here, so that I can get it as an audio, a line out. When I want to have line out on my bench and I don't want to plug in a receiver or something, I can actually just send it to there. This signal comes out here, and then I've got the workshop amp, and this is a great little workshop amp. It's got line in, again, powered, volume control, and it's just a power amplifier, and the 2 outputs here, left and right. That's my speaker outputs. And then I go to my dummy load. Now that has actually suffered a small alteration, which I want to tell you about. I believe I did a video on the project where I designed this thing and built it. And what I had then was the input from this is going to your speaker. So it's coming from your amplifier speaker, for example. You plug it in here instead of connecting it to a speaker. And I had the choice of selecting dummy load or speaker. If I put speaker, it goes to the top left workshop speaker. If I put it in the center, it's off. The signal comes there. It doesn't go to either the speaker or the dummy load. And if I push it down, it goes to a dummy load at the back here, which are resistors, power resistors. If it's on dummy load, I can choose between 4 ohms or 8 ohms. Usually it's at 8 ohm. And there's always a monitoring socket here for the oscilloscope, so I can keep an eye on the signal coming into here on the oscilloscope. This is my left channel, and the right channel was the same. What I found myself doing quite often is having to connect the amplifier output, these speaker outputs, to there. And I had to end up wiring things across. And that became a bit of a pain. So what I decided to do is I decided to pass wires over the top to a switch here and there. And what happens now is this thing, if it's down on speaker, if it's down to speaker, it's taking these inputs. And the same applies for the right-hand side if this is down to speaker. So it's taking these inputs and passing them onto either a dummy load or the speaker at the top there. If I've got amp, it's taking the output from here into there and treating this as the dummy load for this amplifier. So I don't need to pass all these wires and actually connect them. They are connected internally. If I put this on speaker, I can still connect these to any speakers that I want. But it just makes it a lot easier when I want to test a signal from the amp all the way through, and I can just pass it across. Just as simple as switching a switch. Okay? If I have it up there and I put a speaker in here, it won't see it at all. It'll be expecting signal from here. If that's off, I'll get nothing and I'll know something's wrong. So the idea is I can do everything with switching. And that brings me to this, what is it? About 3 foot long, 1 meter long, 1 meter something long, under cabinet device rack. And I've got to tell you, it is pretty cool. It is really, really cool. Everything is powered. There's my amplifier on. My receiver goes on. It's looking for Wi-Fi. This doesn't have a switch. This is totally passive. Here's my, obviously I've got that off at the moment. There's my dummy load, the antenna mini whip. So everything is here. It's right here. I don't have to fiddle with it. I don't have to connect it. I don't have to look for wires and connectors and everything else. It's all here. It's what I wanted. It's what I've now got. And guess what? There's still a bit of space on the right and there's still some space on the left. In fact, there's a lot of space. And this is where I'm going to ask you guys for a favor. A lot of you are fairly familiar with my workshop setup. You've just become a little bit more familiar with what I've shown you today with the new edition. Damn, it looks good. I like it. I really like it. Sorry. But there's a problem. I keep getting asked to do more projects for this rack and otherwise, and I really don't know what else I need. So if you have any ideas of what I could build, it's got to be something that's going to be useful on a very regular basis. I'm not saying it's got to be used every day, but very regular basis that would make sense to build, to design a PCB, build it and put it on this rack. I'm all game. I'm game. I want to do some more. Whether they are the small modules or the double wide modules, doesn't matter. So if you have any ideas, make your suggestions, put your suggestions in the comments below. And who knows, maybe that'll be one of the next projects. So I'm looking forward to hearing what ideas come to mind. I'm sure I'll find something myself, but right now, I just look at it and think, that's it. That's what I want. And just so you know, I've got a lot more of those ladies' magazines, my wife's magazines that I can use to cut on. So I'm not afraid to do the graphic stuff, which is sometimes quite tedious. It used to be worse. Now it's quite easy. I've got my method. It's quite easy. I've actually put my logo on most of them. The last one I'm still printing. I have to rebuild that to get the same logo and the same font and everything else to make it look more uniform. But that's me yakking on again, and that's enough for now. And so what I want to do is I want to thank you for your support. I want to thank you for your attention. I want to thank you for your comments. It's your comments that made me make some of these changes on here and rebuild this thing. And I'm going to post the final PCB on the share section of the PCBWay website. I will put the link to that share in the description below. I'll also put a link to the, actually to the Gerbers and to the final schematic on my Google Drive. That'll be in the description below. And for now, that's about it. I want to thank PCBWay for their support and their boards and making these projects possible and interesting and fun. If you want to support the channel directly, you can do so on Patreon and PayPal. Links are in the description below. And for now, thanks for watching. Bye for now and stay safe.